you're traveling back in time, right? You're traveling back, by the time you get to the bottom here, back to the Cretaceous period, the end of the time of the dinosaurs, 65 million years ago. Now let me ask a question of you guys. Do you know where the world's first dinosaur skeleton was discovered? Haddonfield, New Jersey in 1858. Dinosaurs were known before that. They were known from Europe, where they had some very fragmentary remains, some claws, a couple teeth, some armor plates, and those remains were so scant that they couldn't really tell what they were. That's why they got that name dinosaur. Dinosaur means terrible lizard. And so they just thought they were these big, puffy lizards. That's 1841. And that's the state of the art until Hadrosaurus folkii is found in 1858. And really, that's the world's first good look at what a dinosaur is. Now, what's the world's most famous dinosaur?
T-Rex.
T-Rex, right? Although Dreadnoughtus wouldn't be a bad answer, but it's T-Rex. And T-Rex is a member of a group of dinosaurs called Tyrannosaurs. And T-Rex was not the first Tyrannosaur discovered. The first Tyrannosaur discovered is called Dryptosaurus, and it was found in 1866 in Ceres Park in Mantua Township. Other dinosaurs found in Barnsboro, in Mullica Hill, in Swedesboro, in Pedrick Town. So you guys live in really the cradle of dinosaur paleontology. So it has this rich heritage. Now, going back to the end of the time of the dinosaurs, the planet's very warm, very verdant. It's so warm that there isn't any ice on the land. All that water is in the oceans. There's room up here, guys, if you want to come up closer. And that raises sea level about 300 feet, so high that North America is divided into two big islands. There's a seaway that goes from the Gulf of Mexico to the Arctic Ocean. And so here, we're about 15 miles offshore. The coastline is over near Philadelphia, lined with barrier islands, with mangrove jungles on them. There's dinosaurs on that beach over there. There's a big crocodile there that's 45, 50 feet long. Here you're in about 70 feet of water. If you look over there, to those really tall trees, the tops of those, that's about the level of the ocean here 65 million years ago. Swimming right through where your bodies are now, a couple dozen different species of sharks. We have found 4 different species of marine crocodile here. We've found 4 different species of big sea turtle here. Who saw Jurassic World?
I see more.
You know, the mosasaur? So we find the remains of mosasaurs here. Mosasaurs that are 45, 50, 55 feet long. We find here fragments of them, not the whole thing. So a mosasaur, if you don't know what one is, think about a Komodo dragon. Now think about a Komodo dragon that's as long as a school bus, that has paddles for limbs, that has a 12-foot jaw, and then these things have a second set of teeth at the top of their throat that points backwards to keep you from swimming back out. It's a monster, basically. And we find those right here. Now, most of the fossils that we find here, we find in a bone bed. A bone bed is a thick collection of fossils. And a bone bed can form in 3 different ways in geology. You can have a time average accumulation where one animal dies here one day and 3 weeks later another one dies and eventually the bodies pile up. That happens in like deep lakes and things like that. You can have bones washed in from elsewhere. We call that a lag deposit. Or you can have all the animals die at once and have those animals all buried at the same time. We call that a mass death assemblage. And in the last few years, because we've been able to table off an area there and come at these fossils for the first time from above, processing the death scene 1 square meter at a time, what we see is that a high proportion of these skeletons are articulated, like you are today, right? Your bones are in the right place and they're still touching each other. And you're not going to get articulated skeletons if they sat out on the surface for a long time, or certainly not if they were transported to that location. So we know we have a mass death event represented in the bottom of this quarry. We also know that that happens near the end of the Cretaceous period. Now the Cretaceous ends with a meteor about the size of Philadelphia going maybe 80,000 miles an hour, hits off the Yucatan Peninsula, and it blasts a crater in the Earth's crust that's 110 miles by 12 miles deep. All that rock goes up into near-Earth orbit, circles the planet, and then begins to re-enter. It's got a tremendous amount of potential kinetic energy that it's got to get rid of before it hits the surface, and it does that by heating up the atmosphere on the way through. So for a couple of hours that day, the temperature of the atmosphere got up to well past the broiler in your oven. So if you're on the surface of the planet that day, you're cooked. You might survive in the ocean, but then all that dust and gas in the atmosphere blocks out photosynthesis. The food chain is very short in the ocean, so if you block photosynthesis, the plankton can't do their thing, and then in a couple of weeks, there's nothing to eat, and everything starts to die. So we have these two parallel mass extinctions that result in about 85% of species disappearing in a geological instant. That impact layer has been found in about 300 spots around the world, but no fossils have ever been found in that layer. So here we have a mass death assemblage that we know is close to the end of the Cretaceous, but what's close in geology? 10,000 years, 100,000 years is pretty close when you're 65 million years ago, right? And so we have a provocative question here, which is this that day? And the answer is, we don't know yet. This is a hypothesis that we're testing. In science, you make these hypotheses, and then you try to poke holes in them. And then if you can't poke holes in them, you publish them, and then I can guarantee your colleagues will try to poke holes in them. So we don't know the answer to that yet, but it's possible that the only place in the world where we have a window into individuals actually killed in that pivotal calamitous day that wipes out the dinosaurs, really makes the modern world as we know it, is in a pit behind Lowe's in Mantua Township. Who knew? So that's the science of the site, but an equally important, and I think equally awesome aspect of this place is that there's about 35 feet of this green sand that goes up to that contact there that happens just after that time. It also contains fossils, but those fossils aren't particularly scientifically important. So we can let guests, like the 10,000 visitors that we've had here in recent years, come and collect from those layers. And if you come here like you have today, and you're willing to get a little dirty, and you're willing to try, you're gonna find a 65 million year old fossil with your own hands that you get to take home. That's pretty awesome. And I've seen it over and over. That's a transformational experience for people. When people make that personal connection with their own hands between the place where they live and Earth's deep past, it's kind of mind-blowing. The other thing that people see here is they see my team over there working. They see science as a process, right? Science isn't just a bunch of stuff that you memorize, but science is a way of asking questions about the world. It's a way of receiving information in a rational way about the world. It's a process, and they see that this process is conducted by people. A head and two arms, and eat breakfast, and they look like people. And the message to students is, well, science may seem like this unimaginable, very hard to get into, mystical kind of thing, but you're a people, and science is done by people, and in the future, why can't you be one of them? There's no reason for that. And so this kind of, I hope will sort of demystify that process of how to get into science for people. So our vision here is now that Rowan University has stepped up and saved this precious resource, our vision is to build a visitor center here that will be a center for STEM education, science, technology, engineering, and math, and a center for citizen science. And the world doesn't need millions and millions of vertebrate paleontologists. We need a few. But you get a kid thinking through the scientific method. And once you have that stuck in your brain, you can't get rid of that way of thinking. And then you start to apply that to medicine and engineering and pharmacology and physics and chemistry and all the things that the world needs a lot of, especially now, to find solutions for these existential threats that the planet's facing because of climate change and sea level rise and environmental degradation, etc. And so we really hope to leverage the innate fascination that all you kids have with dinosaurs and with ancient monsters to provide a portal into the sciences and engineering for the kids that grow up in this area, so they don't have to leave the area if they don't want to when they grow up. There'll be places to get educated, places to work right here. So when you collect fossils here, fossils are ancient life, right? So they're not random looking things. They have a form, they have some symmetry, they have some texture, they have a pattern to them. That's what you want to look for. If something is kind of random shaped and sticks out in funny places, probably not a fossil. A lot of what you'll find here are concretions. It's just where sediment has been glued together by minerals in the groundwater and they make irregular shapes, not fossils. Fossils are going to look like ancient life, and most fossils here will be tan or orange, except for the teeth. We get teeth preserved here. Shark's teeth, mosasaur teeth, other teeth. And those teeth still have the enamel on them, and that enamel has been stained black by iron and by not brushing your teeth for 65 million years. And so they're going to be black and shiny when you find those. You'll also commonly find a mineral here that has kind of bladed crystals, and it's blue, and it's called vivianite. And that's kind of a rare mineral, actually, but it's common here. You'll all probably find some vivianite. And for you kids that play Minecraft, you'll find a lot of iron ore here, too.
Yeah.
Now listen, here's the rules. Stay in the fenced-in areas, and don't dig too deep. Don't dig deeper than your little plastic shovel, okay? We have an important fossil layer under this area, and if you dig too deep, you're going to puncture that. And we need to be able to go through that layer in a very, very methodical way so we can map out everything that's there. So don't dig deeper than about this, okay? Everybody got that? Okay. All right, who wants to find some fossils? Yay! We have volunteers stationed around wearing the shirts. If you need help identifying stuff, see them. And make sure you get one of our fossil ID guides. Have fun. Thanks for coming.